Hello, this is Dr. Hein and welcome to the Math Bunker. Today we're going to solve for x in a triangle and we're going to use the exterior angle theorem. We have a problem set up. We have a triangle TUV and we have an exterior angle with an expression of 19x plus 2. Inside the triangle, we have the expression for t, 6x plus 3, and then angle u, this is a u, is 90 degrees. Now we're asked to solve for x, and so let's do a quick review of the exterior angle theorem. Let's say I have a triangle ABC. The three angles are inside the triangle, and we extend one of the lines on one of the sides of the triangle, and we'll call that angle y. And we're going to use the exterior angle theorem to find the measure of angle y. So we'll say that y is the exterior angle. Now, we need to locate the two remote interior angles. The remote interior angles are always opposite of the exterior angle that you're looking for. Okay, so the remote interior angles will be angle A and angle B. And so let's say that angle A is 40 degrees and angle B is 60 degrees. Okay, so to find out what angle Y is, the sum of the remote interior angles will equal the exterior angles, so 60 plus 40 is simply 100, okay? And so therefore A plus B in this scenario will equal Y. Now we're going to use that information, the sum of the remote interior angles equals the exterior angles, to find X in our more challenging triangles. Let's go back to the triangle, and I wrote it out for you. Okay, so over here we had angle T was 6x plus 3, if you recall. And we have a square which on U, which represents 90 degrees. Okay, now the exterior angle is 19x plus 2. And so I'm going to set it up this way. I'm going to call RI the remote interior angles. And there are two remote interior angles. One is the 6x plus 3. The other is 90 degrees. That will equal the exterior angle, EXT, which is 19x plus 2. Now I'll simply solve for x, okay? The first thing I'm going to do is I'm going to combine like terms. On the left side, I have a 3 and a 90. They're both numbers, so they're not associated with any variables. And so I'll put them together, and I now have 93. That leaves me with 6x plus 93 equals 19x plus 2. The next thing I'll do is I'll put the x's on one side of the equal sign, and I'll move the numbers on the opposite side, and then eventually solve for x, okay? I like to move the smaller x over to the larger x, that way everything stays positive. And so I'll take the 6x, and I'll move it over to where the 19x is. So it's a positive 6x. To move 6x over the equal sign, I must do the opposite, the opposite operation. Its operational sign is a positive, so I'll make it a negative 6x, and they'll cancel out. And because I subtract 6x on one side of the equal sign, I must subtract 6x on the other side of the equal sign. And so 19x's minus 6x is 13x's. And then, of course, on the left side, it will just disappear. Now, because I chose to move the letters, the variables, to the right side or over the equal sign, I must move the numbers the opposite direction. So I have a positive 2. Its opposite is minus 2. So I subtract 2, and I must subtract 93 minus 2. 93 minus 2 is 91. Therefore, I'm left with 91 equals 13x. Now, this means 13 times the number equals 91. So we do the opposite of multiplication, which is division. So I'm going to divide 13 by itself. 13 divided by 13 is 1, or 1x. 91 divided by 13 is 7. Therefore, x will equal 7. I'll put that up here. And so x equals 7 because 91 divided by 13 is 7. So x will equal 7. And what I could do with that 7, x will always equal 7. If I wanted to find out what angle T was, I can multiply 6 times 7 and add 3. If I want to find out what the angle of the exterior angle is, I can multiply 19 times 7 and add 2. But right now we're just asked to solve for x. Therefore, our answer is 7. Thank you for joining me in the Math Bunker.